I'm going to find the derivative of phi, which is equals to x squared minus 4y squared at the point p naught, which is equals to 2, 4, in the direction of the vector phi, which is equals to I minus 3j. So we are given that phi, the p naught, and the phi. To evaluate the directional derivative, we have to find the gradient of the scalar field that is given there. So what we know is for a real valued function, phi of xy, the gradient of phi, denoted by grad phi, is the vector partial derivative of phi with respect to xi plus partial derivative of phi with respect to yj. And then we go on and substitute the phi that we have here. So we have the partial derivative of phi with respect to xi plus partial derivative of phi with respect to yj. Then go on and evaluate those partial derivatives. Here we'll be differentiating with respect to x but treating y as if it's a constant. And here we'll be differentiating with respect to y but treating x as if it's a constant. And when you evaluate those partial derivatives, we get 2xi minus 8yj. So that's our gradient there, grad phi, 2xi minus 8yj. So now that we have found our gradient, we then go on and find the directional derivative. And the directional derivative of phi in the direction of the unit vector u is given by grad phi dot u. So that's the formula there for the directional derivative. We are having a unit vector in the direction of the given vector. So we need to find a unit vector in the direction of this vector here. And the unit vector u in the direction of v is given by u is equals to v divided by the norm of v. And for the norm of v, if you still remember the norm of a vector, we take the square root of the dot product of the vector and itself. So the vector that we have there is I minus 3j. So in this case, when we substitute the v into this formula here, what we would get there is I minus 3j divided by square root of 1 squared plus minus 3 squared. This part is as a result of the dot product of a vector there. We'll be multiplying the corresponding elements. And when we simplify there, 1 squared plus 9, it gives us a 10. So we'd have 1 divided by root 10i minus 3 divided by root 10j. So what we are having there, that's our u there. And when we have found the u, we can then go on and use it to evaluate our directional derivative. So we said our grad phi there, and we have our u here. Then we compute the dot product of the grad phi and u as stated in this formula here. So we put our grad phi there, 2xi minus 8yj, take the dot product with the unit vector there. And if you still recall, when you are taking the dot product, we multiply the corresponding elements, then go on and add. And what we would have there is 2x times 1 divided by root 10, then plus 3 times 8 divided by root 10 multiplied by y there. So the result that we get there is 2x divided by root 10 plus 24y divided by root 10. So that's our directional derivative there. So we will need to evaluate that directional derivative at the point 24, this point here. So we go on and evaluate the directional derivative at the point 24, which is our p naught. So I can write there my grad phi dot u at the point x equals to 2, y equals to 4. So what we are saying here, x equals to 2, y equals to 4, we substitute it into the directional derivative that we have just obtained here. So we can then go on and substitute there. And when you do that, put the x equals to 2, y equals to 4. The result that you get there is 2 times 2 is a 4. 24 times 4 gives us a 96. So we have our directional derivative at the point 24 there is 4 divided by root 10 plus 96 divided by root 10. So that's our directional derivative there at the point 24. So what I am saying here is the directional derivative there, we can simplify it to 100 divided by root 10, since 96 plus 4 gives us 100. So we have the directional derivative there is 100 divided by root 10.